So hi all, welcome back. So in this video we'll be talking about the concept of UML class diagrams, and then we'll also be taking a look at the relationships, right? So let's start with the UML class diagrams first. So it says unified modeling language class diagrams are the foundation of object oriented design, right? So what they help us? So they help us to visualize the structure of your system, understand the relationships between classes, and then to communicate our design effectively. So we'll see how to represent a class in terms of UML diagrams, right? So if we see this visual that we have here, so this is kind of an anatomy of a UML class, right? So at the top you have the class name. So in this example, bank account is the class name, and then and the second portion is the attribute. So you'll define the attributes. For example, for class bank account number, balance, float, right? So all these are attributes on this class bank account. Similarly, you'll also have methods, right? So all these things are methods like deposit, withdraw, balance, right? So all these three things are methods that are defined on the class bank account. So this is how you represent a class in terms of UML diagrams, right? So this is a visual notation of a class. So now if you see the small signs that we have on these attributes, for example, if you see minus, minus, hash, plus, right? So we talked about the concept of access levels, right? Earlier when we are talking about encapsulation. So if we switch to encapsulation, we saw this concept of access levels, right? So public means this is something that can be accessed from anywhere, but whereas protected means this is accessible within the package and the subclasses only. But if it is private, that means this is only accessible within the same class, right? So now if you go back to the diagram, so if you see, if we annotate or if you denote something as plus, if you see deposit is something that we denoted as plus, right? So that means this is something that can be accessed everywhere, right? Okay, so now we have understood like how to represent a class in terms of UML class diagrams. Let's take a step back and see why do we have to do it in first place, right? So first thing is design, right? So you can think through your system structure before coding, right? So before even writing one single line of code, you can see what are all the classes, what are all the relationships between the classes, what are the visibility levels, right? How is one class connected to each other, what is the multiplicity. So all these things you can see clearly in a diagram, right? So before you proceed to code. Second thing is you can communicate with each other, right? So you can share it with other developers on the same team, right? So they can also understand it easily. So there is no concept of language, right? So even though the other developers primary language is something others, this acts as a universal language, right? So whatever you write in UML, that can be communicated easily. Second thing is you have a document, right? So you have a document of how your code base looks like. Finally, this is very much important for all the interviews, right? So for all the LLD interviews, you have to draw these UML diagrams, right? So you have to specify the class name, the attributes, the methods, all these things, so that it will be easy for the interviewee to also understand the design that you are doing. So here we can see plus means that this is public, right? So if you see this deposit method, so we have marked it as plus. So that means this can be accessed from everywhere. Similarly, minus means private. If you see account number and balance are private attributes, right? So hash means protected. That means only this class and the subclasses can access it. And this tilde means within the package, right? So whatever we learned during encapsulation, the access levels, the same thing if you want to represent it visually inside a inside a UML class diagram. So this is how you specify the visibility modifiers. Okay, so now that we have understood the concept of UML diagrams and how to represent using that, now let's understand how to represent the relationships, right? So before that, we have to understand what are relationships in first place, right? So it says class relationships define how classes interact with each other in an object oriented design system, right? So whenever, let's say you have two classes, let's say you have a car class and then you have a motor class, right? So how are car and motor classes related to each other? So it's easy, right? So a car has a motor, right? So it has a relationship between, car class and a motor class, right? So this is what we want. So how do you represent these kind of relationships, right? Then there are four types of relationships that we are going to be learning in this video. So starting with the dependency, association, aggregation, and then composition. So we'll come back to the concept of strengths and all these things later, but now let's learn all these relationships, right? So starting with the association relationship. Okay, so now let's understand the association relationship. So it says association is a relationship where one class knows about another class, right? And then it can use its services. It uses a relationship or a known a relationship where classes can exist independently. So let's break down this definition, right? So it says, the first line says one class knows about another class, right? Let's take an example. So let's say you have a teacher class and then you have a student class, right? So teacher class knows about student class and student can also know about the teacher class, right? So one class knows about other class and then it can use its service, right? In this example, teacher can teach the student, can also grade the student, right? So one class can use other classes service, and then the relationship between these two classes is also termed as a user relationship or a known relationship. Now the important characteristic of association is classes know about each other. We saw this. Classes can communicate with each other. We saw this too. But the third thing is classes have independent life cycle. So that means both classes can exist without each other, right? So there is, this is not a strong dependency. Like, for example, you cannot say that a teacher cannot exist without a student or a student cannot exist without a teacher, right? So both classes can exist independently. So this is what, the key characteristic of association relationship, right? Let's take some examples. Teacher class and student is one good example, and then doctor and a patient, right? So a doctor can exist independently, right? So the doctor class can exist independently, and then patient class can exist independently. Same for library, right? So library can exist independently, books can exist independently, right? So this is what the key characteristic. So it says both classes can exist independently, right? And then one class can communicate with other class and both these classes know about each other. Okay, one more thing that I had forget in association is, so how do you represent this association relationship is, so you make use of this solid line with an open arrow, right? So that means you are representing a association relationship between these two classes, right? So now moving on to the aggregation, right? So let's go back to the definition. So it says aggregation has a relationship where one class contains other, right? So this is very important. One class contains other. Let's see an example, right? So for example, if you see, there are two classes, right? A team class and a pair and a player class. So if you see the attributes, team has a name and team has a players, right? So players is nothing but a list of players. So that means team class contains players, right? Right. So one class contains the other class. So that's what we are saying in this definition here. It says one class contains other, but the contained class can exist independently, right? So that means, can this player exist independently without a team? Yes, for sure, right? So player can exist independently. So this is what aggregation says. So it says one class contains other, but the contained class can exist independently. And then it says it represents a weak ownership relationship. Whatever the contained class is there, that class can exist independently even without the main class, right? So that says, right, it has a relationship, right? That means it is a weak ownership. And then parts can exist independently of a whole. Parts can belong to multiple wholes. And then life cycle independence, right? Parts are destroyed when the whole thing is destroyed. So this is important, right? So now let's see this. So in this diagram, child, that is the player, it has its own life cycle, right? Yes. And then deleting a team does not delete its parents, right? This is the important thing, that that we are discussing here. So life cycle independence, it says parts aren't destroyed when the whole is destroyed. So that means these players, like whatever this class, this will not get deleted even though if you delete the team class, right? So let's take another example, right? So let's say you have a university class, right? So a university has students, right? So and then you have a method which says add student, right? And then as usual you have a student class, student has name and student ID, right? So if you see, this is a main class or a whole class, and then it contains the other class, so it contains the student class, right? And the second characteristic is students can exist independently, right? So these students can exist independently. You can create objects of this student class independently, or you can also have students in association with university, right? So here you are creating a university, and then you are associating these two students with the university, right? So even though if you delete the university object that you created earlier, student 1 and student 2 still exist, right? So this is the perfect example of our definition, right? So one class contains other, university class contains the student class, right? But the content class can exist independently, right? So even though if you delete the object of this main class, individual students can exist independently, right? So this is what aggregation says. So if you see in this diagram, you have a university class, you have a student class, and how are you denoting, how are you representing the relationship, that is the aggregation relationship? So you have a solid line and then a diamond, right? So like this you'll have. So this represents has a relationship between these two classes, right? So same thing here, right? So how do you represent? So solid line with a hollow diamond means that is an aggregation relationship. Okay, so now moving on to composition relationship. So it says composition has a relationship where one class contains other and the content class cannot exist independently, right? So isn't it this the same as aggregation, but only one change? If you see in aggregation, it says the content class can exist independently, right? So if you go back to our example, this is a player class, right? So this class can exist independently without the team. But if you go back to the composition, it says the content class cannot exist independently, right? So this represents a strong relationship between the tied life cycles. So this is the small change between aggregation and composition, right? So here also one class contains other class, but the important thing is they cannot exist independently. So let's take an example, right? So let's say you have a car class, right? So as usual in the constructor you have brand, model, and then if you see here we have two classes, right? Engine class and then wheel class, right? So you have an engine class and then you have a wheel class, right? So if you see, this is a composition, right? So engine cannot exist without a car, right? So can engine exist independently? No. Can wheel exist independently without a car? No, right? So that means this is the whole class, right? So this is a main class, and this main class contains these two classes, right? Engine class and then wheel class, but they cannot exist independently, right? So for example, if you see, whenever you are creating instance of a car, right, and then you say car dot start, so automatically it says engine dot started, etc. But when you delete a car, engines and wheels are also gone. So these content classes cannot exist without a main class. So this is what the definition says, and the content class cannot exist independently. So this class, this engine or the wheels cannot exist independently. Let's take a look at another example, right? Right, so composition, right? So house and a room, right? Classic example. A house, in this example, see, house is an attribute called as address, which is a string, and it has rooms, right? So rooms is nothing but a list of this rooms class that we have on the right, right? So this is a content class, right? Room, can room exist without a house? No, right? So this cannot exist independently. That is the first thing. And the second thing is, whenever you destroy the house, the room also gets destroyed, right? So these are the key points, right? So child cannot exist without a parent, right? And the second thing is parent creates and destroys the child, right? So whenever you destroy the house, the rooms are also getting destroyed. So this is a strong ownership, right? So this contained class cannot exist independently without the main parent class. And how do you know denote it? So similarly, like what we have for aggregation, here if you see this diamond has nothing filled in, but here you will be filling. So solid line with a filled diamond means you are representing a composition relationship, and this is a strong ownership, right? So if you go back to this thing, so aggregation is a weak relationship, right? Composition is a strong relationship, right? Why? Because in aggregation, the contained class can exist independently without the parent class, right? So see this example, pair can exist independently without the team class, but here in composition, a room cannot exist independently without the house class, right? And then whenever house gets destroyed, rooms also get destroyed, right? So this is all about composition relationship. So it says dependency is the weakest relationship where one class uses another class temporarily. So the dependent class does not store a reference to other class. It only uses it as a parameter, local variable, or a return type, right? So we'll go back to the example and then come back to the definition again. So if you see this visual that we have, see this. So you have an order class and then you have a payment service class. So in order class, you have this attribute total, and then payment class, you have this attribute gateway. And then in this order class, you have these two methods, right? Checkout and then cancel. So what is checkout doing? So checkout is taking payment service as an argument, right? So it is taking it as a method parameter, right? But it is not storing the reference of this class. If you see in our earlier example, see this in this composition relationship, we are storing the reference of this room class, right? Same thing with this aggregation too, right? So we are storing the reference of a player class on this team class, right? But here if you see in this relationship, we are not storing any references, right? So this class, this payment service, whatever is there, this is just passed as a method parameter, right? So whenever we want to make use of this payment service, we just use it, right? So there is no concept of store references used and then we release, right? So typically how we'll be using this is typically it will be like a method parameter, right? As we saw in this example, right? In this checkout method that we have in this order class, payment service is passed as a method parameter. And then this is a weakest relationship, right? So class A, whatever the order class, uses this class B briefly. So how do you represent this dependency relationship? You use something called as a dashed arrow, right? So something like this that you see between order and payment service. So let's see few more examples so that we'll understand dependency much better, right? So take this example. You have an order class, right? So this is the constructor, and then you are calculating the total, and then you have a method called as print receipt. So if you see here in both these methods, we are making use of a class called as calculator, right? So we are making use of an object that is coming from a class printer, right? So we are using these classes temporarily, and once this method is completed, we are releasing them, right? But we are not storing any reference to these classes on the order class, right? So are we storing anything here? No. But if you go back to composition, see we are storing a reference to a engine class and the wheel class, right? But here there is no reference, right? So we are not storing it, right? And but whenever we want to use, we'll use it, and after that we'll just release it, right? So if you see, we created an object of this instance of this class order, and then calculator printer as usual, and then when you tell order dot calculate total, you'll pass this calculator, right? Same thing for printer, right? So if you see, calculator and printer are not stored in the order class, right? So we don't store the reference, right? So whenever we want, we use it and then we release it. So this is all about dependency relationship. And then how do you denote it, right? So use a dashed arrow. Okay, so now moving on to inheritance, right? So we saw this concept multiple times earlier, but inheritance is also relationship, right? So consider this. So animal is a class, right? So and then you have dog, cat, bird, right? So all these things are subclasses which are extending from a parent class, which is animal, right? So what is the relationship between these classes and then animal class, right? So this is a relationship, right? So that means child inherits all the attributes and methods, right? We saw that. And then child can override parent methods, and then this promotes code reuse, right? So the relationship, inheritance relationship, will denote it like this: solid line with a hollow triangle, and then we call this relationship as a is a relationship, right? So that's all on a is a relationship, right? Or the inheritance relationship. So now that we have understood the concepts of relationships and what are, various relationships in object oriented programming, now let's talk about one small concept, that is multiplicity. So for example, take this thing that you have a person class and a passport class, right? So what multiplicity tells is, how many objects of this person class can connect to a single object of passport class. So we know that we have a relation between person and passport, but the thing that is missing is how many objects of one person class can connect to a single object of a other class, right? There are various types of multiplicity. For example, let's take this example, right? So you have a person and passport, and then what does it say? A person class, one person can have one passport, and then one passport can have one person, right? So this is how you have to read. So you see these small numbers beside the classes, right? So let these numbers, right? These numbers beside the classes, right? So for teacher and student, for student and course. So you see these small numbers, right? So how you have to read? Let's say if you are reading from left to right, right? So that means you have to read it in a way like one person can have one passport, right? So for from left to right, you have to read like this. And from right to left, one passport, one object of passport can be associated with one person, right? This is how you have to read. If you see this one to many relationship, one object of this teacher class, right, can connect to one or more students. Similarly, one student can connect to one teacher, right? I mean, this is not an actual example, but this is how you have to read the multiplicity, right? So if you are going from left to right, you have to take this, right? So let's say you are reading this from left to right. So it says one student can have, one or more courses, right? So this is one dot dot star means one or more, right? Similarly, one course can have one or more students, right? So this says regarding the course. So if you are reading from left to right, for person you have to read this. If you are reading from right to left, let's say from student to teacher you are reading, then you have to take this, right? So this is how you have to read. As usual, multiplicity has various multiplicities. We saw this, right? So exactly one means one instance of a class, right? So one person instance should be associated with one passport instance, and similarly one passport instance would be associated with one person instance, right? So similarly 0 dot dot 1 means, see, dot dot means you can, think like this is or, right? So 0 dot dot 1 means 0 or 1. 1 dot dot star means 1 or more. 0 dot dot star means 0 or more. So star specifies, that more thing, or we can also call this infinite or many, 0 or many, 1 or many, right? Like that. And then m to n means in a specific range, right? So in this example, if you see this is a one to one, right? So one instance of a person class is related to one instance of a passport class. Similarly here, one instance of a teacher class can have one or many students. One student class can have one teacher class. If you see many to many, one student, I told you now how to read from left to right. One student can have one or many courses, whereas one course can have one or many students, right? So if you are leading, you have to read it like this. From left to right, you have to consider this thing, and from right to left, you have to consider this thing. So that's all with respect to multiplicity. So as a practice, what I want you to do is go ahead to this article altogether whatever the relationships that we have learned so far, right? Association, aggregation, composition, dependency, all these things. Using all these things, we'll be building a simple, very simple library management system. So the goal of this example is to understand, right? So what are the relationships in this example? Inheritance, right? For example, a person class can, if you create a person class, and then member and librarian can extend from this person class, right? So this is an inheritance relationship. So we'll understand what are all the relationships are there in this simple example. This is very simple example. So you can just follow this article, read through it, so you'll understand how all these individual relationships are working together and how do we use them to build a simple library management application, right? So this is an exercise. You can, very simple exercise, you can just open this article, read through it, understand what are all the various relationships in this library management system, and then you can practice it, right? So that's all for this video. So we have covered UML class diagrams and all the relationships. So from the next video we'll be starting upon design principles, right? So see you in the next video.